welcome. Uh, my name is João. I was born, I live, and I work in Portugal. I'm a software engineer for Elastic. I joined in September of last year, and I work in the Logstash team. Most of my career has been around developing with Ruby, and I've always have an healthy interest in all things that are event-driven and event-driven architectures. So why are we here? We're here for this guy, and this is Logstash, and this is our mascot, and it has a name because it's a log and it has a mustache, so it's quite clear. So quick show of hands, who knows about Logstash? Good. And of those who has it in production? Cool, awesome. So this talk is quite introductory, so it explains what Logstash is, what is it for, latest developments, what is new in the current version that we have, that has been released like a month ago, and also the next steps, what is the future for Logstash. So what is Logstash? Well, it's an event processing pipeline that is plugin based, it's written in Ruby, and open source. No, that's it. That's my talk. Well, no. So what does that mean, plugin-based event processing pipeline? Well, it's something that looks like this. So it's a three-stage process that allows you to, in each phase, for example, get something from a log file, anonymize that data or some part of that data, and then send it to, for example, Elasticsearch, or send a notification to PagerDuty. So here the combinations can be, well, I'm going to say endless, because there's a lot of plugins that you can use. So to give you a bit more examples of what Logstash can do and where is it used, well, a very common use case is, imagine that you have your web application that has, when it's starting, has just one node, one machine that has a web server, a database, and you kind of want to understand what's happening in your infrastructure. So you want to look at the logs of those applications, and you want to be able to get a big picture of what's happening. And this is where Logstash comes into place by allowing you to get data from the log files of those applications and also information about the operating system and send that to somewhere else. And in this case, and this is something very common, to Elasticsearch, that you can then analyze and visualize using Kibana, which is a visualization tool that reads from Elasticsearch. As you scale and you start breaking down your components to different machines, you kind of get the same thing, which is you put Logstash into each component and get data out of there and send it to something like Elasticsearch. But also, something that I did a lot in my previous work, I used to work for a Portuguese telecom, so you had a lot of very old legacy systems. The people that developed those systems were no longer there, and you still want to be able to get data from one system and send that information to another. The problem is that, well, one system might be able to speak a language and speak through a protocol, the other might not. And this creates an awkward situation, and each component will think that the other one is rude. So this is a problem of multiple protocols, multiple languages, multiple ways of doing things. You can have multiple ways of representing an event in your log files. You can have just one line or multiple lines. Think about the stack trace, for example. And you can also represent that as just a plain text or JSON or XML. And you can also send that information or store that information using Log4j, TCP, UDP. So there's a lot of ways that you can communicate with data. So, and not all applications are ready for all kinds of combinations of that. So going back to the example, that's where Logstash comes into. So it allows you to get data from one side, do some transformations, and then send data to the other side using something that this side can speak. Without looking at languages, looking at a more concrete example, think about an application that can send data through a TCP socket in the form of CSV, but on the other side, you need something like only has like a web API that receives JSON, and that's what Logstash can do for you. And that makes everyone happy. So how does Logstash do this? So Logstash is an open source project. You can get it at that address. And as I said before, it's written in Ruby. Nowadays, it's more geared towards JRuby, and that has a reason, and actually multiple reasons. The first one is that it leverages the JVM and all its goodies. So you have a very interesting garbage collector. You have a lot of mature libraries for everything that you ever need. And also, it opens up the ability to have a JRuby code base, but also communicate in the same JVM with Scala, Clojure, and even Java, obviously. Also, all the debugging tools, all the profiling tools are quite awesome. I love Visual VM, for example. Also, it's a very active project and a very active implementation of the Ruby language. The next version that's coming out soon, it's 9.0.0.0. Don't ask me why he decided to do that version. The last version is 1.7.20. There's actually a reason for that. Is that because the language Ruby is on 2.2, so he wanted to steer away from having similar numbers, so people will then say, well, that's behind the current implementation of the language. Is it ahead? So he just wanted to get out of that comparison between versions, so he just decided to use 9.0.0.0. Also, if you're interested in this kind of stuff, there has been a project started at the Oracle Labs for an internship, and the project was re-implementation of the Ruby language using the Grail or Graal, I don't know how that's spelled, but how's that pronounced, but Graal is a dynamic compiler for the JVM, and it gives you a lot of interesting stuff because it exposes the compiler through a Java API, and now your language can actually influence the compilation of the language. And that, combined with the Truffle abstract syntax tree interpreter, it allows you to have simpler code for generating from your code to actual compilation and actually influence the compiler in runtime, have a tighter abstract syntax tree as you go along, because JRuby is a very dynamic language. So it allows you to fine-tune that abstract syntax tree as you go along the execution. So it's a very interesting project. If you want to know more about this, there's a URL that explains the process and also how to use it, how to test it. You can just download Ruby and this version of Ruby, and then you're done. So going back to Logstash. Oops. Going back to Logstash, the core concepts that you have to be aware of are events, obviously, and events are generated using input plugins. And to give you an example, think about the file input plugin, which reads off a file, and for each line, it generates an event. And it also tags it with some metadata, like when did I see this particular line? I will timestamp it with the current timestamp. Then you have filters. Filters are not just for dropping events and deciding which events you want to take care of, but also do transformations of those events and even go from one-to-many or many-to-one mappings. So to give you two examples, think about, imagine that you have a payload that is a CSV, and you want to deal with each element of that CSV as an individual event. Then you can use a split filter plugin that will break down that message with a terminator and generate multiple events from just one. And on the other hand, again, going back to the stack trace, while you have a log file that will generate one event, which is multiple lines of a stack trace, you can then use a filter called multiline. And then you say, well, I know how the stack trace begins, and if I don't find that initial pattern, then I can say that all the lines belong to the previous event. And then that way, you can collapse multiple lines into just one, and then deal with that block of text as the stack trace. Does that make sense? Yeah. So how do you do this? Well, Logstash is driven by a configuration file. And there you describe how your pipeline will work for your requirements. You just have to describe the pipeline and then start Logstash with your configuration file. That's it. For now, every time that you need to change that configuration file, you have to start and stop Logstash. But that will change in the future. And the configuration file will look something like this. So you have a section for the inputs, a section for the filters, and a section for the outputs. And in each section, you will specify which plugins that you want to use and how to configure them. For example, you can read anything that is sent to this directory and ends with a log, and also get data from a UDP socket. Simple. Then you take that data, each event that you receive, either from a file or UDP socket, and you generate a checksum for that message. For some reason, you might need it. And you base off that checksum of the payload and the timestamp that Logstash tagged it once it came into Logstash. And then you can send it somewhere else. So in this case, you send it to Elasticsearch, and you also send the event back to the command line. It's easy. So there's a lot of plugins, a lot of them. Input plugins, most common ones, file, getting data from RabbitMQ, getting data from Redis, SNMP traps, very useful in network environments. Syslog, same thing. A lot of systems only know how to communicate with just plain TCP and UDP sockets. Things more esoteric, like getting Twitter streams, and each tweet will be an event that you can then manipulate. Filters are, I'll speak more about filters, but the idea is that, like I said, you can manipulate the events that you receive in the inputs. And outputs are kind of the opposite, obviously, of inputs. For every input plugin that you have, you most likely will have a similar output plugin. So you might read stuff from a file, but also write to a file at the end. So to explain a bit more, what's the job of the filters? Think about MySQL. How many of you use MySQL? Oh, interesting. OK, so for example, MySQL has a log file that registers the queries that are slow log, makes sense. But the way that it does it is that for each occurrence, it writes this block of text. At the beginning, you have time, then you have some information about the query, a timestamp, and the actual query. The problem with this is if you're reading off the file, then you get each line as an individual event. And that way, you will lose the ability to correlate, for example, the timestamp and the actual query. So you need that in a single block. So that's not what you want. To do this, like I said before, you can use the multi-line filter, for example. And this will say, well, if I find, so here's this pattern, which is at the beginning of line, I have a time. And if I don't find it, then that means that this particular line belongs to the previous event. And that what we'll do is look for, if I go back a bit, so I look for this pattern, and if I don't find it, so if I go through here, then I will say that this line belongs to this event. The same thing for this one, and this one. That way, this will be compacted to just a single event. And that's what you get. And this also adds a small tag saying that, well, this is a multi-line event. That was something that I generate using the multi-line filter. The problem is that this is still just a block of text that you have to understand and break down. And another plugin that you can use, so you need to do something after doing multi-line. And for this, you have a plugin called Grok. And Grok is just a way of breaking down a block of strings into meaningful data. Well, oops. There we go. You could obviously do this with a regular expression. The problem with regular expressions is this. So what Grok gives you is just a huge list of patterns that encapsulate this kind of regular expressions into names. And then you can describe this block of text using those patterns instead of the regular expression to show you how that's done. And actually, you have a lot of patterns. You have patterns as simple as an IP here or host. You also have composed grok patterns, which is IP or host. So you can just say, well, if I find either an IP or host, then that's what I want. And to specify, to describe this log line, you can do something like this. So I have this fixed block of text that I don't want to capture. Then I have something that I want to put in a variable called time. And this greedy data here will essentially go from here until it finds something that is fixed. So here I stop at the new line. Then you can do the same thing for the query time. I have a block that is fixed, and I want to capture a number, which is the grok pattern. I want to assign it to a variable called query time, and then I actually want to convert that to a float. And why do I want that? Imagine that you're sending this data to Elasticsearch or Graphite or something like that. Then you want to have that as a number. It makes sense. You don't want that as a string. And then you do the same for the rest, the same for the log time, the row sent, etc., and describe the timestamp and the greedy data. And you take that expression that you created, so this block here, and then you say, well, I have an extra filter after multiline, and this is evaluated in sequence. So first I collapsed all the lines into just one, then I take a grok pattern that I want to match in the message field, which is usually the payload. And this way, you'll get everything broken down, not just the message, the payload, but also all the individual elements that you can then use in a system ahead. As I said, there's a lot of plugins. Actually, right now, there's this many, so 53 inputs, 47 filters, 64 outputs, and the list keeps growing and growing. And one of the reasons for that is the new release of Logstash that happened a month ago, so 1.5. And what this new release brought into play was the separation between the core of Logstash and the plugins. That's what I said. The problem was that before, so 1.4, you had everything in the same Git repository. So GitHub, elastic.logstash/logstash had everything in it, so both the core and all the plugins. The problem with that is that if you find some bug in the file input plugin and you want to send that fix to the community, then you have to release a new version of Logstash just for that. Or say, well, you have to wait for the release cycle that can be 1 month or 2 or 3. So 1.5, as I said, brought the separation between the core and the plugins. And now, if you know about Ruby, each plugin is a Ruby gem. So it's kind of a jar, I guess, for the Java world. And that way, you can have separate release cycles. If you find a bug in the Elasticsearch output, you can just fix it and release a new version of the plugin. And then you have a tool inside of Logstash that allows you to do manipulation of the existing plugins that you have in your installation. You can install, uninstall, update, etc. And you can get the plugins for Ruby gems. RubyGems.org is like the central repository and the public repository for all gems that exist. You can also install a plugin, a .gem locally, or even git clone a repository for a plugin and say, well, I want to use this plugin that is in this directory. Then you're done. Also, this allows us to just git clone a repository for a plugin and run its tests individually. Before, you had to download the whole Logstash and execute the tests for that plugin in the context of the whole software. So all plugins right now are living inside of this organization or this user in GitHub, so Logstash plugins. And you can just go there and search and see if there's a plugin that is suitable for you. And actually, Kafka input and output was just released at the time of 1.5, so If you have that in your architecture, now you can use it. So what is a plugin? Creating a plugin has been made to be much easier now. And to understand what a plugin is, and to ease the development of a plugin, we have 3 repositories there under that GitHub organization that is input example, output example, and filter example. And those are just skeletons with a very simple example that you can just clone, rename, and change the API to just do what you need, and then you have a plugin. And what does that API looks like for each of the stages of the pipeline? Well, for the input plugin, it's quite simple. You just have to inherit from a class, obviously. So this is all in Ruby. You have to configure, you have to say which parameters you need on your plugin. For example, you can say, I have a configuration parameter, which is interval, that has to be a number, and by default, it is 5. Then you have a method for doing some bootstrapping, some setup. And then you have the main method, which is run, that takes a queue. You don't have to call this. This will be called for you. And inside of that method, you just have to do something that eventually will have some block of data that you can create a Logstash event with it, and then send that into a queue. And that will be shipped off to the filter stage of the pipeline. You don't need anything else. To think about, for example, the TCP input plugin, you just have to open the socket. When you get a new connection, read data off the socket, and when you get data, then you generate a new Logstash event and then ship it off. The filters are much more simpler. You just have a method that is filter. You get one event, and then you do something with it, and if you decide that your filter matched that event, then you just call it filter matched, and you're done as well. And output is even simpler. So just get a method that is received, and you do something. Imagine for HTTP output, you just have to get that event and execute an HTTP post with that payload. It's quite simple. Once you get that and you developed your plugin, you just have to build the gem using this command, and you always have this file there as well. And it outputs a .gem, and then you can just go to your Logstash installation and do bin plugin install and .gem. So this bin plugin is actually something that we had to develop for 1.5, so to be able to manipulate the plugins that you have. And it has obviously the basic tools and operations that you need. So you can install a plugin. If you don't specify that is a local file, a local gem, it will get it off Ruby gems. It will install it, verify what it needs, download dependencies, etc., etc. You can also uninstall, obviously. You can list the existing plugins that you have on your installation. If you specify just a part of the name, it will try to match the existing things that you have. So in this case, TCP input and output. And also update all the plugins that you have. It will go to Ruby gems, check if there are newer versions, and update them. And the last thing that I mentioned about running tests, if you just want to run the tests for one plugin, you just have to clone that repository, do a bundle install, and that will install all the dependencies for that plugin, and then just run bundle exec rspec, and it will run all the specification for that plugin, and say if it failed or not. So the good things and the very nice things about this plugin system is that it leverages the rubygems.org. So when you publish a new plugin, everyone can access it immediately because it's out there. It also leverages Bundler, which is a tool in Ruby to do dependency management. So you don't have to write anything about that. You just delegate. You just say, I want to install a plugin, and this plugin has these dependencies. Go do your job, and it will pull everything that it needs. And also, it's the Ruby way of doing things. The bad things is that we found some difficulties when doing this, because depending on the situation where you're running Logstash, you will need different sets of gems and different sets of dependencies. When you're downloading Logstash, a clean repository of Logstash, you don't have anything. You just have the code for the core. You need to download all the dependencies. You need to download JRuby itself. And if you're unpacking, for example, a release of Logstash, then you already have all those things. You don't need to download them. If you're running tests, then you need the dependencies, the development dependencies. If you're just running in production, you don't need them. So all these kinds of different sets made our lives hard to play with Bundler because it's not that used to dealing with so many different gem sets. The fix for this in several situations were just to change the way that Bundler behaved. The other problem was Bundler itself, the tool that manages dependencies, was initially written to be used through the command line. So you do bundler install, and it will download everything. You do bundler update, it will update your dependencies. And although it offers an API, so you can just, in your Ruby code, call bundler, it's not that meant to do that. For example, once you do bundle install with the development dependencies, that it will remember that it did that. So after doing the execution, if you don't need them anymore and you want to just have the runtime dependencies, it will remember that it installed previously with the development dependencies. So you couldn't do the reset. And actually, there's a method there saying bundler reset, but that didn't reset. So we had to actually patch the way that bundler did this reset to do reset. Also, one of the problems that we had was we have a lot of plugins that now use jars. And obviously, when you want to manage jars, you want to use Maven or some other tool that will take care of the jar dependencies when you're just calling a single jar. Everything else should be taken care of for you. So Ruby and JRuby has a gem that will call Maven and all those necessary tools to take care of those dependencies for you. However, the version that ships with JRuby was very, very bad. So we ended up just, for our plugins that use these jars, just download them, include them in the .gem, and send that to Ruby gems. This is not an ideal solution. It makes gems a lot bigger. It makes us take care of the dependencies for the jars. We will see if we'll be able to change this in the future. Other problems, it makes it harder to test. So the plugin and the bundler is very disk intensive. So it downloads gems, unpacks them, manipulates all the files that's saying, well, you have this set of gems. So it's very hard to do unit testing on that. And the solution was just creating acceptance tests that we just assume that when we install something and then we uninstall it, if we list it, it will no longer be there. And we just assume that everything else behind it will work. So that's what was Logstash 1.5. For Logstash 2, the next version, the things that we are considering and taking care of are, firstly, resilience. So why am I talking about resilience? If you think about the pipeline that I mentioned, so you have inputs, filters, and outputs. The way that this is implemented is that you have between each of the stages a queue. And obviously, this has been mentioned already in some of the talks. Queues are not meant to be unbound. It's a bad thing to have queues that are unbound. And this is actually something that Logstash does not do. The queues are actually very small. They only have the ability to hold 20 events each, so 20 here and 20 here. So it's just a matter of having a little breathing space when you're doing a pipeline and not block any stage just because you have one plugin taking a bit more time. So you can accumulate a little bit of events if one of the stages backs up. The problem with this is that these queues are, for now, in memory. So if you get something from the outside into the input, and then the input sends it to the queue that it's going to be read by the filters, and there's a crash, then you lose that data. That's a bad thing. So in the next version, what we're implementing is changing the way that these queues work from an object in memory into a disk-based queue. This is being done through memory mapped files, and there's already a pull request that has a lot of the code already being able to do this. And this is something that will be released in the next version. So this way, when you get a crash and you restart Logstash, you'll just have the event there as nothing has happened. The other problem with Logstash, something that all systems have to be aware of, is how to deal with failure. Imagine that you're sending an event out to some system, and the system says, that's an invalid event. That's malformed, or I can handle it right now. I just don't want it. Then you have two options normally. Either you can retry, and it's something that's maybe transient, and you can just try it again, and maybe it will work, or you can discard that event. But it would be nice to have a third option, which would be to call that a lost cause. That event is not going to be handled, so I'm just going to re-inject it back into the pipeline. And that way, I can, for example, log that into a file saying, well, this was a lost event I couldn't handle, but it's not gone. I have it in the file. If you can later, then you can pick that file, pick that event, and do some other transformation and re-inject it back into your systems. And this is what is called dead letter queuing. Another interesting thing is clustering. As I said before, right now, everything that you do on a configuration file for Logstash is through the configuration file. And if you have to change that configuration, then you have to stop Logstash. So in the way of, through the path of creating a clustered Logstash, we have to have a lot of tooling in place and a lot of features in place to be able to do that. And one of them is being able to configure everything on Logstash through an API. If you think about Elasticsearch, for example, the other project of Elastic, everything is spectacularly being able to configure through an API, and everything is configured through the API. So this is also the aim for Logstash. So being able to tell Logstash, well, this is a new configuration file, reload yourself, go fetch the configuration from this place, change parts of the configuration in runtime, and eventually even coordinate a specific pipeline between multiple nodes. Oh, if you want to know more about this, we have an issue that's mostly an issue for discussing this kind of problem and to see how the development for this feature is going. And obviously introspection. In the talk before by Greg Young is saying if you have queues, then you might want to know, or also you need to know how those queues are behaving. So introspection is something that for now Logstash is not very good at, so it's kind of a black box. So if you have the API in place, you can also use that API to understand how full are those queues between stages of the pipeline, how many events I'm processing in each plugin, for example, what is the latency between sending something to a plugin and shipping it back. So all this obviously has a lot of problems in implementing it. When you insert introspection, when you add debugging and stuff like that, it will slow your system down. So it has to be well managed in the way that it doesn't get in the way of performance a lot. So the same thing, it's also being discussed and talked about in this issue of Logstash project. So what else? There's a lot of concerns right now as we grow the list of plugins. So as we have close to 200 plugins right now, how do we know if a certain plugin, plugin number 9073, is a good plugin, is a good thing to use in production? We can't manage all the plugins. We're not that big of a team. So we expect a lot of contributions from the community. But on the other hand, how do we tell the contributions, the contributors that their contribution should have a test, or that it's your contribution that adds this very interesting feature has 200 lines of code and it's all in a single method? How do you communicate this need for having decent code, but and not at the same time not alienate other contributions from that person who's very willing to help the project. Other problems are improving integration testing. So if you think about filters, they're very easy to unit test. You just have input of event and output will be one or more events. So you can do unit testing on filters very well. However, in inputs and outputs, they're inherently drawn towards integration testing. If you have Elasticsearch output, then it's very nice to be able to actually test it against an Elasticsearch instance, because you can't just rely on, if I have an HTTP output, if I use HTTP client from Java, I can expect that if I do the right call on that library, everything is solved. I will not have crashes anywhere. Obviously, every library that we use will have bugs, like Logstash has bugs. So it's nice to have integration tests. We're doing a lot of experimentation with containers, obviously Docker as well, to have proper integration tests. And things more abstract, like we want to have better performance and predictable behavior, expectations, etc. So what now? Go play with it if you don't know about Logstash. It's a great tool. It saved me a lot of time in my old job. File an issue if you have a problem. If you have some expectation when you're using Logstash and you don't meet that expectation, for us, we consider that a bug. So do file an issue if you see something that does not meet your expectations when using this tool. Write a test, it's always welcome. And also experiment not just with Logstash, but the whole Elk stack. So get data from your log files, structure them using Logstash, send them to Elasticsearch, and then be able to visualize and create dashboards through Kibana. Also, you can complain on IRC. It's also an interesting way of communicating with us. I'm JSVD on Freenode in the channel Logstash, so go there and talk with us. And yeah, that's it. Any questions about this? Yes? Okay, so the question was how does the Elasticsearch output works. Especially before 1.4, there were two ways of running Elasticsearch output. One of them was having an actual Elasticsearch instance running inside of Logstash, and the other way was just, well, communicating with a cluster in the outside. More and more, we know that having an Elasticsearch instance running inside of Logstash is a bad idea because you're in the same JVM doing completely different things. So the way that you communicate now with Elasticsearch is through one of three ways. One of them is using the REST API for Elasticsearch, so it's just HTTP. The other two are using the transport protocol that the nodes use to communicate between themselves. So it's a binary protocol, Java, etc. And there's benefits and downsides to each one of them. Between those two ways of communicating using the binary protocol, one of them is just transport, so it's kind of a client for the cluster, and the other is node. Node is actually a way of Logstash actually becoming part of the cluster, starting himself as a node of the cluster and joining the cluster. That has some problems and some benefits as well. One of them problems is you have to be able to, if you have a very tight network, you have to be able to communicate bidirectionally with the cluster and Logstash. Also, if you have a lot of edge servers and you configure that on all of them, so you have a cluster of 10 nodes, which is your Elasticsearch cluster, but then you have 100 nodes sending data to Elasticsearch that are actually part of that cluster, and they're part of the gossip protocol as well. So it's kind of a twisted thing. So either transport protocol or HTTP is a good way. Was another question? Yeah.
I have a question about forwarding your logs from the external server. Like now we use Logstash forwarder, which is a Go project.
Yeah. So
now we can do it with the core Logstash development plugins.
Okay. So the question was how to forward the logs from your edge servers into either Elasticsearch or some other system, right? Or into Logstash, for example. So There is a project called Logstash Forwarder, which is a very simple. Why? Apparently, I have meetings. So there's a project called Logstash Forwarder, and yeah, it's great. There's a project called Logstash Forwarder, which is written in Go, and the job of that software component is just reading stuff from a file and sending that through a protocol that we called Lumberjack. And that's all the thing that that software does. It's very light, it's written in Go. And then you have an input plugin on Logstash that is able to read that Lumberjack. So the architecture would look like a lot of Logstash forwarders, Logstash to do the actual breakdown of the message and transformation, and then send that to Elasticsearch, for example. That is one way of doing it. You can also do that using just Logstash on all of the nodes. The bad thing about that is if you have a very restricted hardware, then you might not want to have the memory penalty of having a JVM on all of those servers if they are very resource tight. Yeah.
Do you recommend using Logstash forwarders? Because previously it was that you did not need to run another instance of Logstash on that server.
Yeah.
And then ship it to another Logstash.
Yeah, the benefit of having Logstash on both sides is that you can do some pre-processing, some transformation before sending that to the central Logstash that has a heavy lifting. So there's benefits and downsides. You're kind of forced to use encryption if you're using the Logstash forwarder project. So it kind of depends on your requirements, I guess. Yes? So you're kind of, so your question is more like what is the problem with the troubles that people find when using this stuff, or?
No, my question is, do people are using Logstash a little bit differently than you presented?
Oh, yeah. There's a lot of use cases for Logstash, and that's the funniest thing is that once you are able to create your plugins, then you can do whatever. For example, I did just a meetup in like a month ago or 2 months ago in Paris, and just for that conference, I created 3 plugins. One of them is a plugin that captures webcam snapshots from time to time. The filter plugin was something that calculated differences between JPEGs using an algorithm, and the output plugin was executing the say command, which translates text into voice. So with that, I created a burglar alert system that when I started and I was just having my laptop like that, and when I came in front of it, it would detect the difference and say, well, you're an intruder, get out. So that's a very extreme case, obviously, but especially when, for example, when I was in my last company in the Portuguese telecom, I didn't use it for having stuff from Apache and sending stuff to Elasticsearch. I had a lot of core routers and network equipments, and I got that information from the core routers using syslog input plugin, did some transformation and structure of that message, and then detected for some particular clients were having some issues, and then I triggered a notification to a system that could do remote resets to the customer's IPTV service and equipments, and then with a restart, usually as everything in our ecosystem, with a restart, the problem would solve itself. So.
You are saying that it starts with some kind of a log, but what you do with them and what's your logic behind maybe much more than just Elasticsearch.
Oh yeah, totally. Actually, this is something that is a problem for me as an employee of this company, is that I'm still learning a lot about Elasticsearch because I didn't know anything about Elasticsearch. My knowledge was just Logstash. I use it a lot. So I didn't even never used the Elasticsearch output plugin in my life, just when I joined the company and started developing on it. So yeah, there's a lot of use cases for that. Good question. Anything else? Yes?
Do you think it's a bad idea to skip Logstash and write directly to the Elasticsearch?
The question is if it's a good idea to just write stuff directly into Elasticsearch instead of using Logstash in the middle, right?
From our application, we would like to log,
Yeah.
using, for example, log4j, and directly to the Logstash.
Yeah. So why do we need Logstash? I used to tell this a lot. Until freaking applications start writing log files in a format that is not meant for humans, then you need stuff like Logstash. If all applications did not write stuff like the MySQL slow log, which is a multi-line thing that is completely out of shape, then you need something to break down that message and structure that and then send that to somewhere else. If you have very nicely structured information, it's already JSON or XML or something like that, then you might not need it, yes. Yeah.
Do you support systemd binary logs?
Awesome question. I have no idea. I don't think so, but do contribute that. No, but we don't have, I think. Any other question? Yeah.
If you do, like, for multiple servers, ship the logs to Logstash, right?
Yeah.
And you use multi-line, well, would that not come like as a, will interfere, for example, if you use multi-line and you get the same log for, you know, same, two different servers, like, for example, first one sending that with stack trace, right?
Yeah.
And in the middle with stack trace, you're sending different log, right? Log event, right? That's on top of that, then it will not be merged, and you have like, you know, partial stack trace.
Yeah, so that's the problem of having two servers sending the same thing that will go through a multi-line plugin. And if you send on both sides, line A and line B, and those arrive in this situation, then you're kind of screwed. The way that to deal with it is by partitioning those events in using some kind of criteria that you know. For example, if you're sending data and you attach the host name, for example, for each machine that you're sending, then you can, on the configuration file, use something that I did not mention, which is conditionals. You can say, well, if the host is something like this, then I want to use one filter. If the host is another, then I want to use another filter.
Yeah, I understand, but for example, these are the same logs, like the same multi-line will apply here and there, right? There's, for example, all the JVMs running on different servers. So then I'll have to write 4 conditions, and in each condition, separate multi-line, which will do actually the same, which is like
Yeah,
code.
there's a plugin right now. I don't know how advanced it is. The idea is to have a stream identity. And if you just the idea is to use that plugin to first separate the streams using some criteria again. So if you say that, use this field to create different streams. But right now, I don't think that will solve the problem. But that's something that we have had complaints about, and something that we have to aim for is breaking down streams and have multiple streams inside of each plugin, for example. Yeah. It could be. I don't think we have anything actually written down for that. But I don't want to sound like a jerk, but please do open an issue about that, so then we can actually, because we read and work with GitHub a lot to decide what to do. So that's actually a very valid input. Yeah.
I have a question about grok. So what is the efficiency of the grok, and how would you compare, let's say, parsing the long line of log in comparison to, let's say, logging already formatted JSON?
Okay, so the question is, what is the performance characteristics of grok, and how does that compare with just writing structured information on the logs? So yeah. Grok will have similar performance to what Ruby has on its regular expression engine. And what that means, it's not the most performance thing in the world. And the big problem that we see with clients is sometimes not just that the grok can be slow, but the patterns and the regular expressions that they built are not well performant. So if we just go through their configuration and see what kind of expressions they built, oh no, just do this differently, and their performance problem is no longer there. But obviously, if you can send data, as he already asked, if you can send data in a structured way, it's much better, always. Yeah.
Is the typical use case to run Logstash on the same machine as you have the log, or on a separate machine?
The question is what is the common pattern to either run Logstash inside of the machine of your application or outside of it? Obviously, especially depending on what kind of performance, what kind of configuration of RAM, CPU, etc. you have on the machine, it might be just better to have that off the server. And you are kind of restricted if your application logs to a file. If it logs to a file, then you have to have Logstash in it. In situations that I used in the telecom, all network equipments would send data off. So I had a machine just dedicated for that. So you're kind of limited on the way that the applications logs. Yeah. Anything else? No? Thank you for coming.